Hello and good evening. Is it mentor got joined or are they waiting?
Hello everyone. Am I audible?
Yes, Priya.
Okay, just wait for 2-3 minutes, then we'll start. Okay.
Okay.
Is my screen visible to everyone?
Yes.
Okay, perfect. Okay, so what we have studied so far, can anyone tell me? Where are we?
We have gone through what is an algorithm and steps to do the analysis and like different ways to analyze it, like asymptotic, theta, big O, and omega operations. And yeah, like we started with the recursive problems and substitution method is something that we have completed.
Great. Yeah. So we are done with substitution method, and I hope everyone is able to get the assignment also, assignment 1. There are few problems related to substitution method and the big O notations and omega notations that we have discussed. So try to do those problems also. This is just for practice purpose. Okay. So today's agenda is to discuss about the other two methods of recurrence relation only. That is the recursive tree method, and the last method is the master's theorem. So we'll try today to complete those two methods. If not complete, I think we will be able to do 80 to 90% stuff, and then uh, remaining things, pending things, we'll do by tomorrow. So firstly, we will start with the next method, that is the recursive tree method. Okay, so first of all, the question came that if there is already one method, substitution method, then why there is another need to do solve for recursive tree method or the master's theorem? So see, there are few problems where you are not able to apply the substitution method, or if you are able to apply, the solution will become quite complex for you. So you have to see that for a given recurrence relation, which method should be the best suitable, which will be able, which by applying that particular method, we will be able to get the solution faster, because it's not like the way we are dealing with the problem in the last session. For one GPC, this only we spent half an hour almost. But when it comes to competitive exams, when it comes to interview questions, no one give you this much of time. So after studying these three methods, when you have a command over these three methods, then you can relate your concepts that, okay, for this particular problem, which particular method I should apply to get my answer as soon as possible. Okay. So one of the very easiest method, I should say, is the master's theorem, which we will discuss after this recursive tree method. So I can say the 90% of the problems will be, you are all able to solve with the help of that only. And in future, we will apply maximum times that method only. It's very rare that I will go for recursive tree or the substitution method. But then there are very few problems where master's theorem we are not able to apply. And for that, we have to go for these two methods. Okay. Now take a look into recursive tree method. Firstly, we will discuss this method in very detail. We'll solve the problems related to that, and then we'll continue with the other method. Okay. First of all, when we should go for recursive tree method, the question which came to our mind. So if two or more recursive terms occur, then usually we used to go for the recursive tree method. This is very important thing that you should know, that when we should apply the recursive tree method, two or more recursive terms, meaning, for example, in the initial conversation of substitution method, which type of problems we have seen, where the dependency or the tth term on the right hand side, you will see only one time, like t of n by 2 plus n. This type of problem we have solved in case of substitution method. But when I'm saying that you are having two or more recursive terms, okay, when I'm saying that we are having two or more recursive terms, its simple meaning is that, like this sort of thing, if you are having t of n by 2 plus t of n by 5 plus n. So if you will see here, there are two recursive terms here. In this particular case, always go for, if you want to find out the big O notation of this type of recurrence relationship, always go for recurrence tree method. This is the thing that I want to make sure by saying this particular line. I hope everyone is clear with this, like what this first line indicates. Am I clear with this point? Okay. Can anyone do me a favor? I haven't opened that Skype chat. If someone forgot, please ping one time. Like there is a class scheduled on 6 to 8. If anyone wants to join, please join. Might be they forget and they can join. Just make them a reminder. I sent it, might be yesterday or in the morning itself, but I forgot right as of now. Okay. So this is the thing that we have to make sure. After coming towards the next point, now what will happen in the recursive tree method? In recursive tree method, basically what we supposed to do? Wait. In recursive tree method, what we supposed to do? We draw a recurrence tree and calculate the time taken by the every level of the tree, and in the end we just add the overall work done at all the levels. No need to understand this point as of now. When I complete one problem, we will move towards this point again, and then this point is clear to you. I hope this first point is clear to everyone. Now coming towards the third point, how to draw the recursive tree. That also I don't want to go in much theory. I will just start with implementing one problem itself, and then I will move towards that particular 2 points, and then I hope everyone is able to understand those 2 points. Just see this method, and I am saying that many people are quite confused with recursive tree method. So just focus on this. Yes, Ritu, what query you have? Please say.
Thank you, ma'am. Ma'am, actually, if I say about this recursive method, then we are already dividing the slides, sorry, not slides, the values like n by 2, n by 5. And when we are already dividing, and in the sum will come up to 1, like 1 or the integer or that value. Then we are also adding the n integer as well. We are dividing by n by 2 plus n by 5 or n by 7, then plus n also. So likewise, how come it will contribute and total come to tn? Like when we are already dividing n by 2, n by 5, I understood. But why we are adding n value also? And so how come then it will be equal to t by n? It should be greater than t by n.
It is equal to t by n. You have to consider when it will be equal to t by n. Your question should be when it will be equal to t by n. See, there are some base conditions. For that we have studied. If there is no base condition, we have to presume. That also I told you in the last section for any recurrence relation. But now your question is that what does n represent? Just we will solve this one problem and you will get your all answers.
Okay.
Just start with this particular problem. In the next, I think tomorrow, we are having one session. In the next session, or maybe in the next session, how part, like how we are able to get this thing, I'll make sure to everyone is clear to everyone. Once we get to a problem of binary search or merge sort or various problems related to recurrence relation, you will be able to get how it is. But the question which you tell, the plus n, why this? So see, what is this representing? The internal meaning of this recurrence relation is that for t of n, we are splitting it into 2 parts, n by 5 and 4n by 5. But for splitting into these 2 parts, first part and second part, there is some, you can say there is some cost associated with it. And this is the cost which you can say is n. This is internal meaning of this recurrence relation. If for n, you divide it n by 5 and 4n by 5, and the cost associated is n, if you will repeat, if you will repeat this particular step again, do you know what you will get? You have to see the pattern. If you will see the pattern, you will observe that in the left-hand side, I am dividing the term with 1 by 5. And in the right-hand side, I am dividing the term with, I am multiplying the term with 4 by 5. Or you can say, I am dividing the term with 5 by 4. So if you will see here, what you will get is, can anyone tell me in the next level what you will get? You will get exactly n by 5 to the power 2, 4n by 5 to the power 2. Is everyone following me? Is this correct, which I have written here? Now these are called the levels. In terms of, when we study the tree data structure, you will get to know in more detail. This is called the root node, and these are called the levels, level 1, level 2, level 3, and so on. Now, when we split this into 2 parts, again, there is a cost associated with this. How much cost? If we are seeing here that if we are splitting n to n by 5 and 4n by 5, the cost is n. If I am splitting n by 5, the cost will be n by 5. And here also, if I am splitting 4n by 5, what I will get? I will get 4n by 5 square, because what I told you, in left hand side, we are multiplying with 1 by 5. In the right hand side, we are multiplying with 4 by 5. That is 4 square by 5 square into n. And what is the cost associated with this? This is again 4n by 5. So what is the overall cost associated with the second level? That would be 4n by 5 plus n by 5, which is 5n by 5, which is equals to n only. Are you guys following me until now? Any confusion in this particular level? Whatever I have written? No confusion? Now moving ahead. What I will do here? It's really simple, but many people usually face so many doubts in this particular recursive tree approach. I don't know why. See here. Now again, what we will do, what I told you, just follow the pattern. Multiplying with 1 by 5. Here again, if I will multiply with 1 by 5, I will get n by 5 cube. And here I will get 4n by 5 cube. Am I correct? It's very simple. We have to just follow the pattern. Now here, if you will see, if you will split here, Kaushiki is asking, ma'am, why it is not 4 square for n by 5 also? Is this point you are referring? Or is this point you are referring? You can unmute yourself and ask me. See, if at this level you are not able to get the point, no point to move ahead. Please, guys, if you have any doubt in between, stop me and ask me. Clarify that doubt. Otherwise, you will lose the lecture.
Ma'am, am I audible?
Yeah. Go ahead.
Ma'am, what I'm asking is that for when we are splitting n, that is n by 5 and 4n by 5, and then again we are splitting n by 5 in n by 5 square and 4n by 5 square. Then why
how we are doing this?
Because for the left hand side we are multiplying it with 1 by 5, and for the right side we are multiplying it with 4 by 5.
Cool. Okay.
So why it is not? Oh, sorry, ma'am. Sorry, it's my mistake. I didn't saw that in the numerator there it is not 4.
Yeah. Anyone, any other one? Please ask me. Otherwise, I don't want anyone to lose this lecture because of this thing. It's very simple if you will understand. Preetham wants to understand. Preetham, Arvind says, please repeat it again. Okay. Arvind, can you unmute yourself and do you know if you unmute yourself and ask your doubt? No, just like
I lost
your doubt automatically resolve. Yeah.
Actually, I lost your voice.
You lost my voice. That's another issue. Okay. No problem. I am explaining it again. Just focus it very much carefully. Then we'll move ahead. We are not in a hurry. Okay. So here we are having n. What I am saying is this is the recurrence relation T of n by 5 plus T of 4n by 5 plus n. The internal meaning of this recurrence relation is I am splitting this n into two parts, n by 5 and 4n by 5. And this n represent the cost associated for this splitting, which is n. Now, I observed the pattern that in the left-hand side, I multiply the value with 1 by 5. And in the right-hand side, I multiplied the value with 4 by 5. It's fine for me. I move ahead. I again split it. I got, if you will multiply the value n by 5 with 1 by 5, you will get n by 5 square. And on the right-hand side, you will get, because you're multiplying right-hand side with 4 by 5, you will get 4n by 5 square. Now, the term is n by 5. Initially, the term was n. So you did this task. Similarly, you did this task also for splitting. Now, if you know that for n splitting, you get the cost as n. For n by 5, your cost will be n by 5. For 4n by 5, your cost will be 4n by 5. Now, the overall, if I will ask you what is the overall cost for level 2, you will say that would be 4n by 5 plus n by 5. That is nothing but itself equals to n. This is what I told you as of now. Is this point again clear to everyone? Are you guys following me? Anyone?
Hi Priya, Sunita here. So are we focusing on n or p of n here?
Yeah,
Because
yeah, we will focus on this n. Because at the end you will get to know that how it's helped. Why I'm just focusing on this n value, what it is giving to me. You will get to know.
Okay.
I hope until this point is clear to everyone. After solution of first problem, everyone is able to get the point. Why I am doing this? What's my intention? Is this point clear? Now, if you add, if I will say what is the total cost of this particular level. So if you will add, this would be n by 25 plus 4n by 25 plus 4n by 25 plus 16 by 25, if I'm not wrong. So if you will add all these terms, what you will get? Again, you will get, I think if my calculation is not wrong, 16 plus 420 plus 424 plus 125, n by 25, which is again n. So what I'm seeing here, now the important point is coming, or important hero of the movie is coming into picture. See here, what we are doing here is we are dividing the term in the left hand side by divide by 5, divide by 5, divide by 5, divide by 5, until what point I need to do. That is n by 5 to the power k, which is equals to 1. Why 1? Because I am considering here that the base condition is when the value met with 1, the way we are doing in the substitution method. Okay. So if you will, this is for the left hand side, because I am dividing the values by 1 by 5, 1 by 5, 1 by 5, 1 by 5, 1 by 5. If you will see, initially you will get n by 5 to the power 1, then 5 to the power 2, 5 to the power 3. If you will continue, you will get n by 5 to the power 4. Until what point we need to go? That will be calculated with the help of this k. Similarly, if you will see here, you are dividing the term with, or I can say you are multiplying the term with 4 by 5, or I can say you are dividing the term with 5 by 4. If I am not wrong, this can be written as n divided by 5 by 4 also. If you are getting my point, this thing can be written as 5 by 4. So what I want to say here is that you are in right hand side. This is for the left hand side. And for the right hand side, what you are doing, you are dividing the term with 5 by 4 to the power k, which is equals to 1. Now calculate both of these values. N is equals to 5 to the power k. Here the value of k is equals to log of n base 5. And here the value of k, if you will calculate, this is 5 by 4 to the power k. So the value of k is equals to log of n base 5 by 4. Now, is these 2 points are clear or not? Before moving ahead, we have pre-assumed that the base condition is 1. Okay, it's if it's not, in the doubt session also someone asked me that, ma'am, what happens if the base condition is not given to me? So we have to pre-assume. So I have pre-assumed. See, base condition is what? When the value of n is very small, correct? So I consider it as 1 in order to calculate the final overall big O time complexity.
I have one question. We won't take the n value also, like n is equal to 10 or n is equal to 20. We can replace the n value or not?
What n value? This n value you are saying, this n value?
Yes, ma'am, value of n, right?
See, we can't replace this n value with 10 or 20 because we want the big O time complexity in terms of this n value only, right?
Okay.
If you will replace this n value, then how you will reach to the target? What's our target? Why we are doing so much stuff? Our final answer is to calculate the big O time complexity with the help of given recurrence relation.
Got it, ma'am.
So this should be a part of our solution, correct?
Got it, ma'am.
Please explain the
Okay.
last.
So now, can anyone tell me? Okay. Okay. Someone asked the question. Please, can you please repeat it again?
Yeah, could you please explain the last two steps, like how you wrote n by
Okay, I will.
k equal to, and the other one as well.
Here in the left hand side, have you seen some pattern, which I am marking again? Have you seen some pattern? With the increase of level, we are going 5 to the power 1, 5 to the power 2, 5 to the power 3, 5 to the power 4. Now my question is, until what level we have to go? This we can find out with the help of, we can generalize the pattern, the way we are doing in the substitution method, if you remember. So this is n by 5 to the power k, and this is equals to 1. I put it equal to 1 because I consider it as a base condition, and I want to find out the value of k. That is that how many number of levels I need to go. This k represents something, the number of levels, you can say. This is the first level, second level, third level, fourth level, fifth level. How much level I need to go in a recursive tree? That can be calculated with the help of this value k. Similarly, this k value is also representing me the number of levels. Now, how this point came? Because here, if you will see this can be written as, let me use another marker. This can be written as n divided by 5 by 4. Am I correct? This can be written as n divided by 5 by 4 to the power 2. This is what I have written. No, not a big thing. Just take the value 4 above numerator part to the denominator, and you will get the pattern. Again, you will get this value. Now, what will happen? Usually, we get the one value of k, and we used to use this. Now, the question is, there are two values of k in our problem. This is the first value which we got from left-hand side. This is the second value which we got from the right-hand side. Which value to consider? Now, this is the main question. First of all, what this k value represent? This represent the number of levels. Now, which k value we need to consider? The one which is having the higher number of levels. If we will consider because big O is the worst case scenario. So in worst case scenario, we have to consider the highest number of levels. If we are able to cover the highest number of levels, then automatically lowest number of levels automatically covered. So if you will see here, can anyone tell me log n base 5 and log n base 5 by 4, which value is the highest? I already told you in one of the lectures that whatever be the log value in the base, having the smallest value, would be automatically higher. So this value is the greatest value. Now, the overall time complexity is what I told you in the first slide. If you will see, the overall time complexity is, if you will mention on the first slide, overall work done at all the levels. Overall work done at all the levels. So at the end, we need to add. So if you will see that higher number of levels is log of n base 5 by 4. And at each level, the work done is n up to kth level. So what is the overall work done? Can anyone tell me? It's a very simple mathematical question. The overall work done should be equal to order of n into k. Obviously, we are having k levels. For one level, the work done is n, or the cost associated is n. So for kth number of levels, the overall work done is order of n into k. So what is the value of k? That is equals to log of n base 5 by 4. Is this point clear to everyone, which I have mentioned right now? Now, if someone asks you, I can say that the value of T of n lies between two values. That is order of, or what should I say? Or what should I say? That the value of T of n that we got is order of n log of n base 5 by 4, or interviewer can confuse you, or in any competitive exam you can be confused if it has written that it would be log of n base 5, because that is for very sure that the value of T of n lies between these two things only. This is the lowest thing we got as n log n base 5, and this is the highest thing that we got, n log n base 5 by 4. So now you can ask me any question if you have. So this is the thing that I have mentioned. Now you are able to get this line also. So in this particular method, what we do, we draw a recurrence tree. The way we draw, calculate the time taken by the entry level of the tree. We used to calculate the value of k. And at the end, we used to add overall work done at all the levels that we did with the help of k into n. Here I multiplied with n because in this particular problem, my overall cost is same for everyone. And that's why I just multiplied. What if the cost is different? If the cost is different, then I need to add each and every level until kth number of times. You will see that particular example in the very next problem. Now, how to draw a recursive tree?
I think we are getting 2n at each level, not just a 1n.
What you are saying?
At every level, the work done is 2n, I believe.
No, it's not 2n. It's n now for every level. If you just add this n by 5 and 4n by 5, what you will get?
But
N.
we do have
if you
the constant that n, right? N is getting split into n by 5 plus 4n by 5 plus n.
What does this n indicates? This splitting is not like n, these are not 3 splitting, these are 2 splitting, and the last n represents the cost associated with that. That's why I mentioned this last n here. That you have to understand.
Cost, it means like of error, right, ma'am?
What you are saying? Again, repeat.
I might be wrong. Sorry for that. Cost, it means like an error, right, ma'am? Error value.
Don't go in machine learning.
Okay, sorry. That's the reason I said already sorry for that.
Means not error function, just like we used to study in AI and ML. But yes, you can say like for splitting some amount of work is required, and that amount of work is you can say n. Okay, so some amount of work is required in this splitting, and that amount of work done is n. So now how we are getting this thing, that you will get in within few days. This is what we have to do. But here the point which you have to understand is the thing that like how we are approaching towards this big O, or how I am approaching towards this omega. So what I used to refer here, that to draw a recurrence tree, we always start from the given recurrence relation. Recurrence relation meaning the dependency of T, and keep drawing the tree until we find a particular pattern among all the levels. See, when I find a particular pattern, I used to infer it with the help of the kth value. What if I'm not able to find the particular pattern? If I'm not able to find a particular pattern, I will again repeatedly do those steps, left, right, left, right, left, right. And I just used to observe that what sort of pattern I am getting. And when I am very sure that, okay, this is the pattern, that each level I am getting the similar type of cost, that is n only, and at each pattern, it is in the left hand side divided by 5 and in the right hand side divided by 4 by 5, then only once I will make sure, then I can calculate the value of k, I can calculate the value of number of levels, I can calculate the overall cost or overall big O time complexity. I think Sridhar, your doubt is cleared by Shubham Sarkar. Okay. Any other doubt? If you will solve the second problem, I hope that your doubt will also be resolved. We are having 3 problems. Yes, this is the correct explanation. You can not say n as a error function, but Taral said right, like it represents the non-recursive part, which is not dependent. If you will see, there is no factor of t that in that particular part. That is called the cost, which simply depends on the input size. Input size meaning the value of n. Okay, so now moving ahead to the next particular problem. Should I move ahead? If you will allow me, all guys, please, if everyone is having any problem, please do let me know. Otherwise, we will move to the next problem and you will enjoy that problem also. Should we move? I got confirmation only from 3 or 4 people. How many students are there in the class? 57. Okay. Okay. So just try with this problem. Now I want to give you some time for this particular problem before giving me myself the explanation. I want anyone, let's see how many people are able to understand the problem number 1. Let's see. I want to give you just 2 or 3 minutes for you. You just need to tell me what is the value of k you are getting in the left hand side and in the right hand side. Sri Teja already find out. Great. But I will not reveal. I will give everyone 2 or 3 minutes. Might be, this is 37. 40, I will tell you. 3 minutes for you all. Just please be calm. Have pen and paper. Just solve it the way I told you. And just calculate the value of k. Might be these people are wrong, which they are telling they're fast. And you are right. So just take your time. What is the overall time complexity you guys are getting? Those who already solved it? Because this is not that much uh, easy question. Overall time complexity, I am saying order of this, big O of this, omega of this. Final answer, what you are getting? Do spend some time. That's why I'm saying. I think the answer is wrong. I don't know how you guys getting this answer, but I feel this is wrong. Should I start now? Or do you want some more time to solve by yourself? No, no, no. Exactly. Icha stated one point, just not note this point and do your work accordingly. This is the hint for everyone who is stating answer so fastly. If you will observe, at each and every level, cost is not same like the previous scenario. Accordingly, you have to solve. Taral Desai saying is correct that it is a GP series forming. Accordingly, you have to solve. Ratio of 4 by 5 in GP. Now you are moving in the right direction. Now can anyone tell me the correct answer? In GP series, always remember one thing, that when the value of R is less than 1, just like the previous scenario we have discussed also, then if you want, you can go step by step and calculate the value. But what you will see at each and every time, that your time complexity is of 1. You can take a note of this for your faster calculations. If the value of R is less than 1 and you have to calculate the sum of GP series, maybe up to kth number of steps, your solution will always form some constant which is having the value which you can consider as of 1. It is just for faster calculations. If you have time, do step by step only. So now let me give you the solution. I have give you more than enough time. Okay, so what we are doing here is that we are dividing again the value of n. There are two splits, that is n by 5 and 3n by 5, and the cost associated with the split is n. Now here, if you will see, again there is some pattern. The pattern seems to me like that. In the left hand side, multiplication with 1 by 5, and in the right hand side, multiplication with 3 by 5. This is the pattern which I am observing. I might be wrong. Just be flexible and think like this way only. I might be wrong, I might be right, but let's do it in this manner only for a starting point. Okay, now what I will get, if I follow this sort of pattern, I will get n by 5 to the power 2, and here I will get 3n by 5 to the power 2. How much cost is associated with this for this split? If this is for n split, n by 5 and 3n by 5, the cost associated is n. So here the cost associated is n by 5. Now again, if I will follow this kind of pattern, again in the left hand side I will get 3n by 5 square, and in the right hand side I will get 3 square n by 5 square, and the cost associated here also 3n by 5. What is the overall cost? It will be 4 by 5 into n, right? This is the cost which I am getting. If you will now solve this and calculate the total cost, if you will split here also, what you are getting? Anyone is getting some answer here? Yeah, 16n by 25. which I can write it as 4 by 5 to the power 2. If you will solve here also, you will get n by 5 to the power 3, 3n by 5 to the power 3, and so on. And add these terms, you will get 4 by 5 to the power 3 into n. It means I can write this term also as 4 by 5 to the power 0. This term is 4 by 5 to the power 1. Means at each and every level, what you are you following some pattern level wise? What pattern you are getting? 4 by 5 to the power 0n, 4 by 5 to the power 1n, 4 by 5 to the power 2n, 4 by 5 to the power 3n, up to so on. Now the point is that how many levels we have to move on. The next point is, okay, here I stopped working because I found some sort of pattern. Now I have to work on the number of levels I have to move on. Now let me open the new slide. Okay. Now I know that in the left hand side, what I was doing is I was multiplying with 1 by 5. And in the right hand side, I was multiplying with 3 by 5. So what I can infer here, I am getting the value as n by 5 to the power k equals to 1, or n by 5 by 3 to the power k equals to 1. If I will calculate the value of k here, what I will get, n is equals to 5 to the power k. The value of k is equals to log of n base 5. And here what I will get, n is equals to 5 by 3 to the power k. I hope this thing is clear, that from 3 by 5, why I'm writing 5 by 3. Because if you're multiplying anything with 3 by 5, you can say you automatically dividing the value with 5 by 3. That's why I'm saying it like this. Now, if you will calculate the value of k, you will get the value as log n base 5 by 3. These two things are also clear. I hope. If anyone is having any doubt in finding kth value, can you can tell me. Okay, can you repeat this step? I will repeat this. If you will see here, there is some pattern. If you will see here in this particular tree, let me go back. There is some pattern you are following. N by 5 to the power 1, 2, 3, up to so on. You have to go to the left hand side. You have to go on n by 5 to the power k, which is equals to 1. Why 1? Because I considered it as a base condition. If you will see here, what you are, I can write it as n divided by 5 by 3. So I can say that we are dividing the term with the 5 by 3. So in right hand side, what you are doing is n by 5 to the power k equals to 1. This is what I have mentioned here. Is this point is clear to everyone? Before moving ahead, is this k value? Now, can anyone tell me which k value we should consider?
5 by 3 log n base 5.
Exactly. And why?
Because that's a smaller value compared to log 5, log base 5.
Yeah, this is the greater value, you can say. And we have to find the exactly lower base, bigger value. This is the you can say short trick to remember this thing. If you are having a lower base, the overall value of logarithmic is bigger. So now I will consider this value. Okay, we are done with finding the number of levels, but this is not our solution. We have to find the total amount of work done. Now, for calculating the total amount of work done, we have to add in each and every level. Now, for first, if you will see, for first 4 by 5 to the power 0n, you will get for the first level. For the second level, you got 4 by 5 to the power 1 into n. For the second level, if you remember, you got 4 by 5 to the power 2 into n. how many levels I am considering? I am considering 4 by 5 to the power k levels into n. So what can I do here? I can take the value of n as common, and I will do 4 by 5 to the power 0, 4 by 5 to the power 1, 4 by 5 to the power 2, up to so on until 4 by 5 to the power k, where the value of k, now you can put it. What is the value of k? For finding the big O value, the value of k is equals to log of n base 5 by 3, if you remember. Right? This is the value of k. So at this particular, this is the total. Now anyone can ask me, why ma'am you are adding this thing? Initially in the very first problem, you are just directly multiplying it, and now you are adding it. What's going on? Anyone can give me the answer why we are adding in this step, and in the previous problem we just multiplied directly? Or is that the same thing or not? Many
Because
people
we
have the confusion of this also.
same n repeated for k times.
Exactly. We did the same task in the first problem. You can add 1 by 1 up to kth value. What I did, I just multiplied it. Because why I multiplied? Because at each level I am getting the same answer. But here I can't multiply it directly. Why I can't multiply it? Because at each and every level I am getting the different cost. Now I can solve this particular thing. If you will see here, the overall value of common ratio R is 4 by 5, which is less than 1. So what I told you, that if the value of R is less than 1, you can directly write it as order of 1. So the overall time complexity is order of n. Or if you want, you can solve with the help of the sum of GP series. What is the formula? A into, I think, R to the power n minus 1 and 1 minus R to the power n.
1 minus r.
Is this correct, or it's different?
It's the opposite one. 1 minus r is 2, because r is less than 1.
So okay, so it's 1 minus R to the power n upon 1 minus R.
Yeah.
Correct, because R is less than 1. Very true. So here, this is the formula. You can put the value of R as 4 by 5, n as log of n base 5 by 3. And but if you are working personally, then for your reference, you will do, it's a good habit. But when we are solving it in any competitive exam, like for GATE and in any sort of interview, they are asking to solve the recurrence relation, and you know the trick, then you can directly imply it to get the answer. This is correct. Are you guys getting my point? Is there any, now if I want to say that what is the omega part, how you find out the omega thing, then
Can we solve it just for one time? That one.
Yeah. That we will do. If we want to find out the value of omega, then what we will do? We just replace the value of k as log of n base 5. That's it. So if you will replace this log of n base 5, again the value of r will remain same. If I'm not wrong, value of r is 4 by 5 only. Then also you will get omega of it. So what can I say, or what can I infer from this? That the value of t of n again lies between two things. It is omega of n and big O of n. So you can say that the overall time complexity, usually people ask this only, but you have a sense of this also. Now coming towards that particular thing, we are having a series of 4 by 5 to the power 0 plus 4 by 5 to the power 1 until so on, until 4 by 5 to the power log of n base 5 by 3. And outside we are having n. So what's the formula we have written? A into 1 minus r to the power n divided by 1 minus r. Now what's the value of a here? What's a is representing here? A is the first term. So what's the value of A we'll consider? And what's the value of R? And what's the value of N? Tell me. Value of A will be, value of R will be, value of N will be. Value of A is 1. Value of R is
4 by 5.
4 by 5. How we calculate the value of R? It's just, we have to consecutive divide it. 4 by 5 divided by 1. So this is 4 by 5. What is the value of N? Value
Log
of N
5 by
is
3.
log N base 5 by 3. Correct? Just put the values here. 1 minus 4 by 5 to the power log of N base 5 by 3 divided by 1 minus 4 by 5 into N. That N is there. Now, if you will calculate this, this will be 1 by 5. I think so. 5 will go above. So this will be 5 times 1 minus 4 by 5 log of 4 by 5 to the power log N base 5 by 3. How can we solve this problem now? Can anyone tell me with the help of logarithmic skills or properties which you have studied?
We can always write log x base A.
Do I have written something wrong, Sri Teja? I have written something wrong, which you want to mention. It is n plus 1. Where you are mentioning?
The n should be log n base 5 by 3 plus 1.
Where you guys are mentioning? 1
Use
minus r to the power n. Value of n is this, no? Log of n base 5 by 3, if
plus
I'm not
1,
wrong.
plus 1. Because we are having 0 to log n base 3 terms, right? So the overall it should be log n base 5 by 3 plus 1.
Okay. It's fine. It's okay. If you will not consider this plus 1. If it has also, you will not consider. Otherwise, you will get again confused for in terms of calculation. Just go with this. You will get the similar answer only. That's a constant thing, no? Plus C. That's what you're mentioning. Right? So now, how you will solve this particular equation? You can take this value of n ahead and 4 by 5 in that power. Am I correct? Are you getting my point? What I am saying is that what we can do here is n to the power log base 5 by 3 and here 4 by 5. This is what I'm mentioning. Is this correct? Or way of writing down this particular term?
Do we have any formula like this?
What you are saying?
Do we have any formula for this expression?
Yes, we do have. No, we have used this various times. Like if we are having something in base and this power, we can move it here and the n term can go here. If I'm not wrong, I told you in which slides, I haven't remembered, 9 formulas or 10 formulas of logarithmic. In that also I have mentioned.
I'm actually referring the same, but I couldn't find out any formula related to this.
There should be one standard form. There should be one standard form, maybe in terms of A.
Ma'am, the expression is n into log to the base 5 by 3 of log 4 by 5, right?
To the power.
Yeah, right.
It's a power.
No. Sorry, it seems to be because of my bad handwriting.
Okay, we
Correct?
got it. Yes.
So now I don't know what's the answer of this particular calculation, but it would be really small. That's why overall this term would be constant and you will get the value final as O of n.
So
0
you
point something you should
n
get.
into log to the log 4 by 5 base 5 by 3. Is it log into or n into or n
Yeah.
over?
n to the power log 5 base 5 by 3 4 by 5. We have used this formula in the previous lecture also while calculating this GP term only. Correct? So just don't go into much mathematics. You can just refer it any source, any source you can refer it. This logarithmic formula. This is really common. Just what I did is this is not in the power. First of all, my handwriting is very bad. So here you can just put the value of n here, and I just replace this term as coefficient term as above part. I will show you. Might be in the next particular problem also. Again, we will came to this particular formula. We always use this kind of formula. Okay. Is this point is clear to everyone? How we are approaching towards the recursive tree approach? Is there any confusion in that particular part?
At the end, you are getting n square, right? So we have one n outside. The very first n. N into 5 minus.
It's not m square. Just calculate this value. What's the value you are getting? I'm saying that this value should be very small, that it's approximately equals to 1. And overall inside this term, you will get some constant quantity.
No, how can you get something?
I have to use the calculator to solve this.
No, I am not.
Might be this is 0 point something.
Minus 0.4 it is.
Okay, you are getting minus something.
Yes, ma'am.
No, Priya, what is my question?
So that's why it's
yeah. Like, what is the value?
Yeah, go ahead.
4 to the, like, can you go to one more slide? Like, can you open an new slide?
Okay, let me open it. Yeah.
So we have 1, can you write it down? 1 minus 4 by 5 to the power of log n base 5 by 3.
To the power of log n base 5 by 3.
Yeah. So
yeah.
What is the final expression for this?
What I told you is that you can mention it as n to the power log base 5 by 3 4 by 5.
Okay, this is something that you are getting inside the braces, right? So outside the braces, there was one more n. If you refer the previous slide.
Yeah, that we are having one more n. Correct. You are very correct. Now, if you will solve this particular, no. If you will solve this particular expression now, if you know n to the power 0 is constant 1, so you can't say it as n square if inside this as 1. Am I making some sense to you?
No, that is not going to be 0, right? That will be definitely some constant.
Exactly. That's what I'm saying. That would be definitely some constant.
No, I'm saying only the power is the constant, not n to the power of the value. I might be correct, like my understanding might be correct, but I just wanted to be clear. I'm sorry. See,
I just want to say that this expression which you are getting now, after solving this is approximately equal to 0. And we know you can consider it as approximately equal to 0. I'm not solving it. And because of that, overall expression which you will get is some constant, not exactly 0. This is not exactly 0, but you will get some constants. And anything multiplied with n, some constant is order of 1. Multiplied with n is this time complexity that we get. Don't focus on this n, just focus on the power of n also that we are having. Might be this confused you because you are saying that inside this is n and outside also n. That's why it should be somewhat approximately equals to n square, but it's not like that.
Okay, got it.
Okay.
Thank you.
And usually, as I already told you, I have to mention also, I should write it on the next slide for your clarity, that whenever the value of common ratio, if the value of R is greater than 1, then definitely you have to calculate step by step. But if the value of R is less than 1, then you will always and always get the time complexity. I'm talking in terms of big O, order of 1, the constant term you will get. So you have to just see the value of R if it's less than 1 or greater than 1. Is it fine for everyone? Now we are again distracted with the GP series, but the main purpose here I want to mention is just the concept behind the recursive approach. Is this clear to everyone? The thing where we started, that how we are approaching towards this. Exactly, Taral Desai said the very good point here, which I forgot to mention in between all these things. I want to mention this, that because now what result we have concluded here is that we are getting the omega of n as well as the big O of n, if you will see here. So that's why we can say that it's theta of n. Am I correct? Am I making sense to everyone after understanding of these three key terms? I hope that everyone is able to make some sense that why Taral Desai said this particular point. Yes, this point is very much correct. Absolute point. So now can anyone, everyone is able to get, I think, some sense after solving two problems that first of all, you have to see, it's not like whenever there is a recurrence relation, we should go ahead with a recursive tree approach. As you have seen that it's quite complicated, it's quite lengthy, and it's taking time also. And as well as it's a similar case for substitution method also. So you have to be very careful in terms of the timings. You don't have to spend so much of time in terms of calculating this recurrence relation. In the upcoming days, I will not even solve one by one, the step by step. I will directly say that, okay, the time complexity of this recurrence relation is order of n square. And you also in your mind are able to cope up with that. Okay, why is she saying that its time complexity is order of n square? That is only possible with the help of the Master's theorem that we will see. But Master's theorem is not at all applicable with this sort of recurrence relation where we are having more than one recursive term, two or more recursive terms, I would say. In that particular case, this particular methodology, whether it be Master's theorem or substitution method, will fail. In that particular case, you should know this particular approach. And the approach is that you have to find the pattern in left and right. You have to solve for the value of k to find the value of k. If someone is not, please mute yourself. There is so much background noise. Please take care of that. Okay, thank you. So here you have to find out the value of k. After calculating the value of k, just you have to find out that at each and every level, initially when I give the problem number 2, everyone is able to solve it in a hurry within 1 or 2 seconds, because might be, I'm not sure, but might be they consider that the cost is same. But usually the cost is not same. If the cost is same, you can easily get the answer. If the cost is not same, you have to go into much depth related mathematics where you have to find the GP series. And for that also you have to, if the value of R is less than 1, I told you, if the value of R is greater than 1, you have to calculate the value. In that way only we are able to calculate these things. Now this is another variety of problem, but before going to this 3 different type of recurrence relations, this is another different problem. Am I making sense to everyone? Whatever we have cleared so far, is these points are clear to everyone? Any doubt, any sort of query, please ask me. Before going to this problem, I want to clarify each and everything, whosoever is present in this class. Is it clear? Should we move ahead? Okay. Okay. So just try now this particular problem. I'm just giving you maybe 3 or 4 minutes of time, do everything just the way we are doing, but here just focus that the value of splitting is not 2, the way we are doing in problem number 1 and problem number 2. Here, if you will see, it will split into 3 parts. The problem is very similar. It's not complicated, I would say. But yes, this is what the thing that you have to focus on. And do let me know what's the answer you are getting in terms of Bigo or in terms of Omega. Both of the answers. What you are getting. Just take your time. Until 7:15, I am giving you the time, 4 minutes. Then we will move ahead with this approach. What values of k are you getting, guys? I hope until that point everyone should be clear. I hope you all are getting 3 values of k. What are those? Anyone? It's very lengthy, is it?
Becoming more complicated once we go into the next level. Might be we may get some answer, but yeah, it will be like a time consuming. I think
Okay.
there might be some other good approach to solve this rather than because.
Ma'am, actually we are forming a GP again, 1 plus 3 plus 9, like that.
But I was asking about the
And
k
it's
value.
constant.
I'm asking about the k value.
K is
3k values you should get. That
log
should
5
not
and
be
log 2 and log 3 and
again say log and base
2, 3, and 5, like that.
exactly. That's what I am asking. That's what I am asking to you all. That what's the kth value you are getting?
And
That's
the
correct.
work,
That's
and,
correct.
and work done is
Then
constant, C3, C9, C, like that.
okay, correct. Now after that, which k value should be chosen? The out
log
of these
5,
three
log
values.
n base 5.
That's also correct. See, everyone knows the approach now. I'm very happy. Everyone is able to understand the approach. My target is to make you understand the thing that I want to deliver. I think that you are able to get. You all are able to get. Yeah, that's the right way of
Ma'am.
doing. Yeah.
Ma'am, that means for calculating A, we no need to do steps, right? We can even calculate itself from the question, right? For n by 2, n by 3, n by 5.
Exactly. That's what.
Yes.
Exactly. From the question itself, we are able to see for just to make you understand.
Yes.
I'm following step by step, step number 1, step number 2. But if your mind is trained now itself, then it's well and good. You don't have to do n by 2 to the power k equals to 1, 3 by to the power k equals to 1.
By seeing
Your
itself,
mind
we can get
itself
the values.
says, okay, by seeing this question, we can say, exactly.
Yes, ma'am.
We can say. The only time which can be spent full in this type of questions is only in the GP series. I can say that, okay, there you can spend maybe 1 minute, not more than that, on that also.
But I'm struggling with
any of the exam.
pattern, ma'am. Finding the pattern is difficult. That's a problem we are facing in logarithmic calculations.
It's not difficult. In finding the pattern also, it's not difficult. If in maximum questions, I'm saying 99% of the questions within three levels, they gave you the pattern. It's just we have to follow this. Like, okay, it's coming. I hope that everyone is getting in the second level 3C. In the third level, they are getting 9C. In every level means you don't even need to mention anything in the fourth level. In every question, you will be able to get the pattern in second or third level if you are able to get it. I haven't seen any question where I have to go until 5 or 6 levels to get the pattern. It's so easy.
Okay, ma'am.
Very rare that any question will come in any competitive exam also. They also know that people have lesser time to spend in each and every question. They can't give you. And similar is the case for interviews also. They can't give you such type of questions which will be time consuming.
Okay, ma'am.
So should we move ahead with such problem, with the solution of this problem, or do you want more time? Anyone is saying something, or should I move ahead? If not, please mute yourself. If you are saying, then please say. Okay, I think everyone is waiting for the solution now. So I will move ahead with the solution thing now. Okay. So here again, what we have to do, again, there is a splitting of n by 2, n by 3, and n by 5. And the cost associated with this is C. Now, when you split this, what you are getting is, in the left-hand side part, you are dividing it by 1 by 2. In the middle, multiplying it with by 1 by 2. In the middle part, you're multiplying it with 1 by 3. In the rightmost part, you're multiplying with 1 by 5. Similarly, if you will follow the similar kind of pattern, you will get n by 2 to the power 2, n by 2 into 3, n by 2 into 5, if I'm not wrong. Again, the cost associated with this is also C. Similarly for C, here is also C. And similarly, you will get three kind of trees here, three kind of subtrees here. So this is something which you will get 3C. Here you will get 9C. So my point here is that the pattern which we are getting, somehow I am seeing, is 3 to the power 2. The next level you will get 3 to the power 3, 3 to the power 1. And here I can write it as 3 to the power 0. Are you guys following me until this point?
Priya, just a second. You are saying the second level, the sum of these terms is a C, right? But that is not the case. It is 31 by 30 and 31 by 31.
we are summing the cost associated with this. What we are writing always in whenever we are solving a question, we are writing the term which is not dependent on t, which is independent of t, which is not dependent on recursive calls. C is the term which we are writing. C is the cost associated with it. In the previous question, if you will see, what we have written is this term. This term here I wrote. This term here I added. If you will see in the previous question also, this term I wrote, I mentioned also. So now if in this, so this term, this C term is here. Now it's not N. Usually we have worked for N. But in this particular question, we have given that the cost associated with this is not dependent on N. It's a constant quantity, which is a C. So if the cost is C, for n by 2 splitting also into 3 parts, the cost associated with this is again C. Again, for this 3 splitting, the cost associated with C, it is C. Again, with this also, this is C. So we need to add the overall cost for this particular level. That would be C plus C plus C. That is 3C. Again, if you will split into 3 parts, again the cost is C only. But this C is how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times, 9C. Similarly, you have to go on. Am I making sense to everyone, or is there any confusion in this?
Actually, I am confused in the second level. Like you are saying, we are getting 3C here, whereas in the previous slide, like we have just taken the sum, which was giving you the 5 by 4.
Wait for a second. Previous slide. This slide you are referring?
This
so
problem,
here the cost associated. In this problem, the cost associated is same as the split. For n, I am splitting it into n by 5 and 3n by 5, and the cost associated is n. For n by 5, if I am splitting it, so whatever I am splitting, the cost associated is also n by 5. So I am not adding this n by 5 and 3n by 5. I am adding this n by 5 and 3n by 5. The cost associated with that. If in this question they have mentioned me not n, C only. Suppose in this question also they have mentioned me C. So the question, again, I will change it. I will say this is C and C. So the overall cost is not this. I will say the overall cost is 2C. Still there is a confusion? I think still there is a confusion, right? I think I am getting your point, like where you are
both the equations are
your
different.
thing is
Both the equations are different. In first equation there was no C, there was no cost associated. Like it was there, but it was related with the n only. There was not explicitly, it was not declared explicitly. But in our problem third, it is explicitly declared at C. This is the difference.
We always add the cost part. We will not add this part. In this particular case, in this particular question, this thing is same. N by 5, n by 5, 3n by 5, 3n by 5. But this is the splitting and this is the cost. In the next question, which we are discussing right now, the cost is different. This is not same. Who is saying same or different? This question is saying. Here it is n. That's why we have used n. Here we have used n by 5, 3n by 5. In the next question, they say to me to use C. So at every split, my cost will remain same. That is C. So what will be the size at each level? Size will be different at each level. This is 3 to the power 0 C. For the kth level, the size will be 3 to the power k into C. Sridhar is saying it right. Yeah, Go ahead.
You just please explain again the concept of C and how you are making this tree in the problem number 2.
In the problem number 2, what the same point you are confusing? Yeah, this is the problem number 2. What you are saying?
Yes, ma'am. Ma'am, what I am saying that first of all, you have written n. Then you have split into two parts, n by 5 and 3 n by 5. Okay, because here the cost is n. So in splitting, it becomes n by 5 and 3 n by 5. Then again, you have splitted n by 5 into 2 parts, n by 5 square and 3n by 5 square. Is it right?
Yeah, right. Let me give you again to everyone. I got your point where your confusion came. Let me give you a sample example to avoid all sort of confusion. Might be I can try. At least I can try for myself. Okay. So here I am having t of n by 5 plus t of 3n by 5 plus n. Consider this as a one question. And another question is, and this only I want to mention, t of n is equal to t of n by 5 plus t of 3n by 5 plus c. These are the two questions. Okay. This n is splitting into two parts as it's clear from our recurrence relation, that is n by 5 and 3n by 5. And the cost associated with this particular splitting is given to me, which is as it is n. That's why I mentioned it as n. Because for n value, I have split it down into two parts and the cost is same, which I have split it. I mentioned the cost as n. Again, if I will split it again, because in the left hand side, I have to divide the value by 5. I do it like this. In the right hand side, I will get 3n by 5 square. Again, I did the similar step. I split the value of n by 5 with these two things, and the cost associated with this step is n by 5. Because in the question itself, it's mentioned that whatever be the cost you have mentioned here for splitting purpose, the similar cost is used here. That's why I have used here. So here, if I will split it again, I will get 3n by 5 square because I have to divide by 5 in the right hand side and I have to multiply with the 3 by 5 in the right hand side. And here also the split value is 3n by 5 because the similar pattern I have to follow. Now, if you will see, I have to add these two things, the cost part, and this will be 4n by 5. These two things. Now coming towards the solution of this. Again, there is a splitting of n by 5 and 3n by 5. But in this particular case, they say to me that the cost associated is C. So I have to mention it C only. So if I'm splitting it again to n by 5, and I will get n by 5 to the power 2 and 3n by 5 to the power 2. So the cost associated with this split is C. Again, if I will split here, I will get 3n by 5 to the power 2, 3 square n by 5 square. The cost associated with this is also C. So the overall cost is now 2C. Here, if I will see the cost associated with this split further into 2 is C only. So here the total cost is 4C. My pattern here is now 2 to the power 0, 2 to the power 1, 2 to the power 2 into C. So here the number of levels I have to go is 2 to the power k into C. But here the number of levels I have to move is to calculate the value of k, that is on the left hand side and the right hand side. That is either the value of k is log of n base 5 or the value of k is log of n base 5 by 3. But here My main point to mention is I'm not adding this split thing. I'm not adding this thing. I'm adding the cost thing always and always in each and every question. Now my explanation is clear for those who are confused with N and C. Who is the one who is confused? You can ask me any doubt at this point. Who is asking me? I don't know the name of that person. Who is she?
Yeah, ma'am, it was me. It's clear now.
Before you, there is some girl who is asking me the query. Is that clear to everyone now? Any doubt? Okay, perfect. I hope now it's clear to everyone. If still not clear, you can tell me. I can again maybe form a new pattern to explain this explanation, because this is the most important and crucial point to understand. So in case 2, what is the value of k? That you have to calculate, that how many times it will move ahead. That I will show you. This is the thing that we are doing in the third question. So coming towards this particular question, now the question arises that what is the value of k? This is what we have to find out. Correct? This is the cost. But what is the value of k? That we have to find out with the help of these three values. That n by 2 to the power k is equals to 1. So here the value of k you are getting is log of n base 2. In another case, n by 3 to the power k is equals to 1. Here the value of k you are getting is log of n base 3. In the next case, n by 5 to the power k is equals to 1. The value of k you are getting is log of n base 5. So what should be the greater value you have to take care of? This is the greater value, I think so. So now what you need to do? You need to add each and every term up to kth times. You can't multiply it directly. So what's the overall time complexity? What's the overall time complexity that we are getting? We are getting 3 to the power 0 into c. Because we have to find out the total work done, no? So how we will compute that? We have to go until 3 to the power k into c. So we can take c as common, 3 to the power 0, 3 to the power 1, up to so on. What is the value of k? The value of k is log of n base 5. See, now again we will use that property which I told you earlier. Here the value of r is greater than 1.
Sorry to interrupt. It's log of n base 2, right? It's omega, right? We are calculating the worst case, right? So log of n base 2 k values.
We are calculating big O.
Yes, big O.
Worst case is big O.
So
Yeah.
the
So
k values
which
log
value
of
should be?
We have to take log of n base 2.
Correct.
Yes, okay.
Correct, very correct. So here this value, I'm wrong. This value is greater. Out of these values, whichever be the lower value in the base is the greater value. Very correct. Thank you for mentioning this point. Okay, so this is log of n base 2. Very correct. So this is log of n base 2. Now, value of r is greater than 1. So the formula would be a into r to the power n minus 1 upon r minus 1. What is the value of a here? 1. What is the value of r here? 3. What is the value of n here? Log of n base 2. So if you will calculate here, what you will get is 1 into r to the power n, that is 3 to the power n. Sorry, what is the value of n? 3 to the power log of n base 2 minus 1 upon 3 minus 1, which is 2. It's a constant. Just forget this. Just forget this. Constant terms don't need to worry. Now just focus on this term. Forget this also. Just focus on this term actually. Now this is something which you can written as n to the power log 3 base 2. And I believe this value is 1.5. So the overall time complexity is what you can say O of n. 1.58. So to be very safe, you can say it's O of n square. Or to be very precise, you can say O of n to the power 1.5. So this is the way, n to the power 1/5. Or it should be written as this way.
N root n, isn't it n root n?
What?
N root n.
What you are saying?
N root n.
N root n. This is what you are saying?
Yes. N to the power 1.5 means, isn't it n root n?
Okay, this is 1/2 plus 1, 3/2. Yes, you can say, I think so. But someone is mentioning that it's what's the exact value of this thing? Log 3 base 2? .584. So I think the safest way to mention this is order of n square. The safest way to mention it's order of n square. Okay, you can mention it like this, 3/4, because it's also, if you will consider 1.5, it would be 15/20. It's 3/4 only. So you can take it. It all depends on the MCQ part, like whatever the options given to you, and if there is no option given to you, then you can take it anyway. Okay, is this things clear to everyone? Is this question is clear now? Any doubt in terms of this approach? With this, our recursive tree approach is completed. Now, after that, we will start with the next approach, if you will allow me. Yeah, this is what I'm saying. In the third question, if cost would be n, then it would be n/3. Let me check. Okay, you are saying that in this particular question, let me create another slide. I don't want to disturb this slide. Let me create. What Rishabh is saying, that if in a question it is given that the value of t of n is t of n/2 plus t of n/3 plus t of n/5 plus n, right? This is what you are mentioning, Rishabh. This is your point. Am I stating it correct? Yeah. So what you will do now? Now here your point should be valid. Like this is n/2, n/3, n/5. So here the cost associated is n. So here now the cost associated with this is n/2. The cost associated here is n/3. The cost here associated is n/5. So the total cost is, you have to add this n/2 plus n/3 plus n/5, whatever value you are getting. Whatever value you are getting. And so on. Then you have to follow the another pattern. This is another story then. Someone is saying its value is 31/30. I don't know it's right or wrong, but it's the correct way. It's the correct procedure to solve this kind of problem. But the query that is that I didn't even notice that the values are same, and that's why you might get confused. But it's really good that there is a term C here, so that you get a clarity that we are not adding these split terms. we are adding the cost function. In the very first line, we have studied that we have to find the overall work done. Work done means overall cost. What is the asymptotic notation? This is what it is telling, that how much time it is taking to compute any function. Now, is this point is clear to everyone? Any further doubt? Should we move ahead to the next theorem, Master's theorem, our last method? If you all allow me. Okay. Okay. So let me fetch now new slide, and let me save this slide and end this, so that we can be ready to start our new and the last part of this particular recurrence relation solving. I hope my screen is visible to everyone. Okay. So let's get started our last recurrence relation method. And I can say this is the method which we will use very much frequently because of its less hectic quietness. There is very less computation is required in solving this Master's theorem, because in when we studied the substitution method or recursive tree method that we have seen, there are so many GP series we have to solve in order to compute a final big or time complexity. But here, if you will see, it's quite simple, and it's quite favorite for everyone. So like in the very first line, I have mentioned that this is the easiest method and direct method to find the recurrence relation. But again, there is some constraint that you have to see while solving the Master's theorem, while solving any recurrence relation with the help of Master's theorem. Like I told you in the very first slide of the recursive tree approach, that you have to take care of that when to apply that recursive tree method. If there are more than two recursive terms present in a recurrence relation. Similarly, when we should apply the Master's theorem, we should apply the Master's theorem when the value of T of n is given in such kind of format, or it can be transformed in such kind of format. That is A of Tn by B plus there is function f of n, where you have to see that this value of A, these constraints are also very important. The value of A is always greater than equal to 1, as well as the value of B is greater than 1. And f of n is a function which is a positive function, like n, n square, n cube, n log n, anything which is related to the function of n. I hope this thing is clear to everyone. Correct? Should we move ahead to the next slide? Okay. Before moving towards these cases, I would like to show you a demo example that how we, what I was saying, and how we are able to compute any sort of problem with the help of Master's theorem. See this problem. I think this problem we have solved in substitution method also, and if not, we can solve it with the help of substitution method also. This is the problem given to us, correct? Now, if firstly, in case of Master's theorem, you have to see that whether its form is similar to this form, which I told you in the very first slide. Is the value of A, second thing you have to see is the value of A is greater than or equal to 1. Is the value of B is greater than 1? The constraint that we have discussed in this particular slide. After seeing all these things, okay, we are sure that yes, it seems that everything is quite fine for us, then only we have to go for the master's theorem. The very first point that you have to take care of. That's also fine. If function is constant, that's also fine. It's not a problem. Constant function is also fine. Now, what the next step you have to do? You have to just calculate the value of n to the power log a base b. This is the very first thing, or I can say the very first step that you have to perform in order to compute any sort of problem related to Master's theorem. So if you will calculate the value of n to the power log a base b, what is the value of a here? If you will compare these two equations, value of a is 2, value of b is also 2. So log 2 base 2, this value will be 1. So this is n. So now you have to compare the value of n log a base b and the value of f of n, which is assigned to you, that is n log n. Just compare these two equations and calculate the value of a, calculate the value of b, calculate the value of f of n. And I hope that everyone is clear that the value of f of n is n log n only. Correct? Now you have to see. What you have to see is which value is the greater one out of these two. You have to see which value is the greater one. Anyone?
N log n.
Exactly. If anyone remembers that we have discussed in the complexity classes, if you remember, the
Yes.
order from first to might be 11th or 12th points I have mentioned on the whiteboard. That's because I want to show you in this implications in terms of the Master's theorem. Okay, so basically what it now just move towards these 3 points which I want to infer here. First step is always you have to compute given, firstly you have to see that whether the Master's theorem is applicable or not. If the Master's theorem is applicable, then the very first step of yours is to calculate the value of log a base b. Now you have to see that after calculating the value of log a base b, whether this value is equal to c, less than c, or greater than c. What is c? This c is, I think, f of n it's mentioning. I have just copied it from the from other web page because I won't able to write this in the PPT this form, log of a base b. So the main point here to mention is that to calculate the overall time complexity, what you need to do, the very first step is you have to pick up the point that the value, what is the value of n to the power log a base b, or I should say this is the second step. The very first step is to check that whether the value of the given recurrence relation is applicable to the Master's theorem or not, because there are so many scenarios where you will see that Master's theorem is not at all applicable. For example, you will see that the value of a is less than 1. For example, you will see that the value of b is less than 1. In that particular scenario, you won't be able to apply this Master's theorem. After that, you have to calculate this. Now, whichever be the value greater, whichever value is the greater, that would be the time complexity. Now you can ask me, ma'am, what will happen if the value of n is here also we are getting the similar value? In both cases, we are getting the same kind of value. Then what should be the scenario? In that particular case, you have to multiply your value with the log of n. So, for example, just move towards this particular question. Can anyone solve and tell me what's the time complexity you are getting? the things that I told you, according to that, don't focus on those three conditions. I'm telling you those three conditions only. It's just that that would be a more mathematical explanation, which I want to give you at the end. But what I told you is very simple thing. Just to get the correct answer, very easily you can get it. See how much time you took for calculating this particular answer. I think maybe 1 second, 2 second, 3 second, or maybe 15 second at max. The same problem which we are trying with the help of substitution method, the same problem which we are trying for substitution method, it took me about, maybe you can say, 15 minutes. That can be solved with the help of 15 seconds. That's the main reason that why Master's theorem is always quite frequently used for any of the students and in any of the exam. So my main recommendation is here that whenever given a recurrence relation, your first task is to check that whether Master's theorem can be applicable on that particular recurrence relation or not. If that is applicable, then please go ahead with the Master's theorem. If that is not applicable, that's the scenario, then think over it that whether we should approach for the recursive tree approach or we should approach for the substitution method. So similarly here, what I told you, that at n by b plus f of n. So the value of a is 2 here and the value of b is also 2 here. So here we will calculate again the value of log a base b. So its value again you will get log 2 base 2. That is nothing but n only. Now the value of n log a base b is, and the value of f of n. That is what you have to compare. The value of this you get as n, and the value of f of n you are having as n square. Which value is greater? N square. So the overall time complexity is order of n square. This is what my point only. And now if I will tell you at the concluding line these 3 points saying this point only, but somewhat in different way. Okay. Let me tell you one more example before going to that point. Just again solve this and let me know what's the answer you are getting. This is the case which I was mentioning, that when you calculate the value of n to the power log a base b, you will get n to the power log 2 base 2, which is equals to n. And f of n is also 2. Sorry, f of n is also n. When you are, see, when I think that first point is clear, that whatever value be the greater, that would be the big O you can consider. But here those values are same. In that particular case, you have to multiply with the value of your answer should be f of n into log of n. That is order of n log n, I want to say, is the correct answer of this problem. Not O of n. I'm not saying that just calculate the value of this and just let me know the answer. I'm saying just 2 points I have mentioned in terms of Master's theorem as of now. Just 2 points. First point, I have mentioned that you have to focus that whether the Master's theorem is applicable or not. For that, I have mentioned you the constraints. The second point, wait, let me open a new slide here. The second point which I mentioned here, which you have to take care of, the very first point is whether this Master's theorem is applicable or not. Second point is, if it is applicable, calculate the value of n to the power log of a base b, and you already will be provided with function n. If If they are not equal, these two values, the value which I have written on the left hand side and the value which I have written on the right hand side, if these two values are not equal means some value should be greater, either this value or this value. That would be the answer. Order of whatever be the greater value you getting. The way we do in problem number 1 and problem number 2. If the value of LHS and RHS are not equal, and if they are equal, like the previous case that we have seen, in that particular case, your complexity would be O of f of n into log of n. This is what the Master's theorem is. That's it. This is what the Master's theorem is. You have to come. This is the main point. This is the calculation that we have to do. Very bigger calculations we have did in substitution method and the recursive tree method. But here, if you will see, just a small calculation we have to do. We have to just compare. Suppose the RHS is greater, that would be the time complexity of f of n. If the value of RHS is greater, the time complexity is order of f of n. If the value of LHS is order of n to the power log of a base b. See, so much means that's the main reason why I am saying to you that just whenever it's a Master's theorem application, apply it. Just this thing you have to calculate. And what those three cases are? Those three cases are this only. 1 case, 2 case, 3 case that you are saying to me, ma'am, please explain it. If I will explain you those 3 equations, no, everyone will leave the class. For sure, after 5 minutes, everyone will be gone. I am alone who is teaching you. But the main point is, if you will not go in much mathematics of that, now if you will see those points, these are these points only which I have referred in some quite simplified way for you. If you will solve this, okay, this is quite a challenging problem which will take time to me. I can say this is, so I want everyone, this I will give you as a homework for tomorrow. I will not touch this problem as of now. The problem is that T of n is equal to T of square root of n plus C. As it is clearly visible. Okay, so I will not say anything for this problem. But this is a challenging problem, or you can say homework for you all to spend some time on this particular problem today. And then we will start our next tomorrow's session, which is at 12 p.m. again. We will move back towards the same timings. So we will start our next session tomorrow, where we will start with this particular problem, and then we'll continue further. My next thing is to cover the arrays data structure, because that data structure is algorithm which we will read, having a tomorrow. Then we will start our first algorithm, divide and conquer. Am I audible now? Okay, so what I was saying is that we will start with the same question, that is this question, challenging problem. You will try today, and then we will discuss tomorrow the arrays data structure in very detail. After that, we are ready to start our very first algorithm module, that is divide and conquer. So I hope until now, our first module, you can say, is completed. That is the analysis part, where we have studied what is analysis, what do we mean by asymptotic notations, big O, omega, theta. Then we will discuss how we are able to find from the recurrence relation, the time complexity. But after tomorrow's session completion, we are good to start with our new algorithm module. So yeah, I will share these slides and it will be uploaded soon on your dashboard also, and I will share the slides in the Skype also in the group. So I think so far everything is good for everyone. Everyone is able to understand everything. Correct? Yeah, we will discuss the assignment problems in the doubt session. I already tell the students in the last doubt session, we will discuss. I just want to give you some time to spend and we'll discuss the answer key. Okay, then I think we are good to leave this session. We'll meet tomorrow again. Bye-bye, everyone. Thank you. Bye-bye.